Hi there. Well, the sun's just come out and that's a bit bright, so just give me 30 seconds. Can't barely see. So today's daily revision question is one about crumple zones, and I will read that out and I'll get that out to you in just a little while. I think this one was a little bit hard, so can you let me know, like, I don't know if you feel like there's a better format for these, if you feel like these are being useful to you or not. Some of you gave me great answers via email, and just don't be shy, put your answers into the comments there. And I understand that. So I'm going to ask you, please put them in the comments so that we can have a bit more of a discussion about these answers. So today's daily revision question, which tomorrow I'll be back to go through the answers to, is about crumple zones, and it goes a little something like this. Explain with reference to Newton's laws of motion how cars designed with crumple zones can make serious injuries less likely for high-speed collisions. Use estimations for typical forces involved in these collisions. So there's two parts to that. Firstly, explain how a crumple zone works essentially, and then use estimations to work out some typical forces involved in these collisions. So there were some really great answers. Harriet's answer was really, really excellent. That was the comment on the previous YouTube one. That's a really, really good answer, and we've got some great ones by email as well. But maybe the A-level one was a bit too hard. I think hopefully you thought straight away, Finland's equation was the kind of response that we were looking for. It's a tricky one using the Finland's equation, especially when they do what I did to you, which I didn't give you all the information for the Finland's equation. I gave you information for magnification. So let's go through that now. I'll start with the GCSE bits, and then the GCSE students can kind of tune out, and then I'll go through any chat that anyone's got, and I will have a little look into any comments or any kind of bits, questions that you've got. So we start with just the basic idea. I said to you that my daughter, who is 75 centimeters tall, was 4 meters away. So let's imagine that to be her. And I've got a set of lenses and a camera, and this represents the lens. You don't have to do one of these diagrams, but it helps you understand what we're talking about. So that's the object there, 75 centimeters tall. And I wanted you to work out what lens you needed to use for this. And for GCSE students, you just needed to describe the image. So if you get one of these questions, then start always by doing one ray from the top of the object parallel to the axis. Terrible drawing there. You'd obviously do that with a ruler in the real deal. That is a ray of light from the top of the object to the lens. You'll get a mark pretty much for doing that. Take that down through the principal focus and straight on. Okay, that's that one there. And this is a converging lens, that's why the arrows point out. And then do one ray from the top of the object all the way through the optical center of the lens. Okay, and where these two rays cross, that is the top of the image. Now that is nothing like to scale with what we're talking about, but I wanted to do that because describing the image is a very useful diagram to kind of understand. The image is inverted, okay, it's upside down. The image is real because it's formed by where real rays of light cross, and if we were to put a screen there, we'd get an image on that. And the clue was, well, it's a camera sensor, so you've got to have a image on the camera sensor to actually, to detect that light. The real image has to be there. And it is actually diminished, okay, because to fit on the 35mm sensor, it's diminished. So that's the kind of GCSE thing. That's just describing the image is all I asked you to do if you were a GCSE student. Now, A-level, I also asked you to calculate magnification if you're a GCSE student. So let's just do the magnification bit. Then GCSE students can tune out briefly, okay? And this is actually part of the puzzle for finally working out the focal length and telling me which lens you should have used. So magnification is image height over object height, which is 35mm over 750mm, because I told you she was 75 centimeters tall, which is 750mm. That magnification comes to 0.047. Well done, Harriet, you got that right. That's fantastic. 0.047. So the image is 0.047 times the height of the object. And then from there, you actually use this other definition, this is A-level stuff now, of magnification, which is V over U. And just let's talk about where V over U are on this diagram. U is the distance from the object to the lens. That's U there. V is the distance from the lens to the image. That's V there. And then lastly, F, the focal length, which is what we want to work out here, is the distance from the lens to either of those focal points. So, you know, if you had actually realized, oh, I'll have to apply the thin lens equation here, and you just actually shoved in some focal lengths and one of these two numbers, but you realize you didn't know the other one, then you would get a mark for showing that you knew to use the thin lens equation. So make sure you do that. So basically, the other definition of magnification is V over U. So the ratio of this length to this length. And we know the magnification, so we didn't ever need to know U. So you can work out, we didn't ever need to know one of these two for the question to get the final answer correct. And you can substitute this into this equation and derive an equation without M in it at all. So you didn't have to really calculate magnification, but it works for if you work the number out, you get the correct answer. Incidentally as well, I've stayed working in millimeters throughout all this because I want my final answer in millimeters. And with this, as long as you use the same units on either side, you'll be okay. So rearrange for V, which is mu, and then magnification times by U, which is the distance from the object to the lens, 4,000 millimeters, 4 meters, gives me a distance from lens to image, which is V, 186.7 millimeters. Okay, and then that number into the thin lens equation to work out F, is what I've done there, 1 over V plus 1 over U equals 1 over F. So F is 1 over this number here, so which is 178 millimeters. Now I asked you to pick out of the 4 lenses that I have for that camera, which were 28 millimeter, 135 millimeter, and 85 millimeter. And the obvious one, what you would want is a larger than all of those. You'd want 178 millimeter lens if possible, to have her as large as possible, but we didn't have that option, so the largest one was the 135. So that would be your answer, and your final mark would be for stating 135 because that's the closest to 178, which is what you ideally would want. I hope that makes sense. So there's another question coming tomorrow. Again, please have a little chat with me if you don't mind, like what's going to make this work really, really well for you? Is it the timing I'm getting wrong? Is it having GCSE and A-level in one kind of thing? I'm hoping that you can see how these questions I'm designing can be thought about in a GCSE level or an A-level lesson level. Maybe at the minute you would rather I split these up, but I don't know how I'd do that and still just do one a day. Maybe it's the timing. Okay, is there a time that suits people better? But you've got a whole day to find this video and have a little look and you know, give your response in the comments. So tell me, because you guys watch this, but you're not giving me as many question responses as I'd ideally like. So this question was about crumple zones today. So I'll be back tomorrow for sure, and we'll go through an answer to this crumple zones one. Let me just get it absolutely right. Explain with reference to Newton's laws, so there's a big clue in there what we really want, how cars designed with crumple zones make serious injuries less likely in high-speed collisions, and use estimations to calculate typical forces that you might have in high-speed collisions. Okay, so let's have a couple of questions in the chat as well. Let's get to them, and then I'm going to go ahead and end the thing. Yeah, lens is a hard lane, that's why I picked this one, and I think that it's one of those bits that's quite new on these new syllabuses, so I think that it's worth having a little go over that. It's not necessarily the best, not necessarily taught as well as some of the stuff that's been there forever. How many past papers should you do daily minimum? Wow, gosh, daily minimum past papers. Like, it'd be hard, especially if you're going to school at the minute as well, it'd be hard to do, I think, more than one in an evening. So that's fine. If you're doing one past paper an evening at the minute, you're probably working at a pretty high rate. If you're at home on your own, then maybe 2, 3, you know, like they take a couple of hours. But as I've said it to you loads of times before, I think there's about 6 hours of work to do on any past paper. There's basically 3 times the length of the paper. So if it's a 2-hour paper, there's 6 hours of work. So it's do it in the time allotted. Take your time over the marking and make sure that you've got it completed to the highest possible quality, and then, so that's another 2 hours to mark it yourself and make sure the answers are perfect, and then look at the examiner's reports and that's another 2 hours of really analysing why is it you don't get these marks? What is it? What's the key you'd need to know? What's the common errors that other people make? And how are they going to structure these questions in the next time? How do you? What's the clue to how you're not going to get it wrong the next time? Hope that makes sense. Now then, there's another question there about sleep. Sleep is so important. It is definitely better to sleep properly or keep a steady routine. Is it better to sleep properly? Well, I wouldn't say they were mutually exclusive. In fact, I'd say sleeping properly is part of a steady routine. So I'm not quite sure what you mean by that. Maybe you can elaborate on that while I just chat about sleep. Sleep is so very important. And I personally, I know that I don't always need to have 8 hours sleep in every single night. I just know that as long as I, over the week, get a good amount of sleep, then I feel good. And actually, I read an article which is a bit of evidence that says that's a fair enough way to do it. That like as long as you kind of sleep 8 hours one night, then you can get away with 6 hours the next night. Okay, it's kind of about not having a sleep debt. And I think that's a good way to do it. But I think that the evidence shows really that young people, especially teenagers, want about 8 or 9 hours sleep. And especially in this exam period, you don't want to be working all night and then suddenly have to get up at 9 o'clock get into school for 9 o'clock in the morning to start that exam. In fact, you want to be used to getting up in the morning, so it's not a bit of a kind of change to your routine. So I would keep normal school hours, and I would aim to be in bed by 10 o'clock every night from now until the end of the exam period. And just if you do that, you're giving yourself the best chance. I mean, like, hey, it's only for a little while, isn't it? You know, you can, after that, you have this amazing summer coming. You can, and this is what I did, you can spend, well, I didn't spend it yet. You can stay up whole nights playing computer games if you want. That's what. Well, I also obviously went out and partying. I was very good at partying when I was young. You can then change a routine and you can have a different routine over summer. But right now, focus on your exam period and being in the right frame of mind. And I would suggest you just stick to that. Get to bed by 10. Have a good solid 8 hours sleep. Get up at 8. Be ready. Start work at 9 o'clock. Make that your body's routine so it's not a shock when you have to get in for the morning exams. I've picked a new window and it's a bad window to go in front of because the sun is so bright. Oh, I see. So is it the question like, do you need to make sure you always get up at the same time or do you need to make sure you get more sleep? So I would say, yeah, get up at the same time. Some nights you might have a little bit less sleep, but I would say a good routine that has 8 hours of sleep in it. So go to bed at 10, get up at 6, that's when I get up at 6, but or go to bed at 11 and get up at 7, but whatever, so that you feel good at 9 o'clock. I've got to just dash off a bit earlier, Rachel. So today's question is about crumple zones. So it's explained with reference to Newton's laws that how crumple zones work, essentially, how they reduce serious injury and make some estimations of some typical forces involved, use some calculations to make some estimations of typical forces involved in collisions. And where can you get hard physics questions? I think we chatted about this one last time, didn't you? If you look at all old past papers and you just do the last few questions in each of the old past papers, there's going to be plenty of really hard ones for you there. All right, dudes, I'm going to jet off then. Thanks a lot for watching. Leave your response in the comments. Go back to the last one if you've got a good response, and some of you have emailed back and said that's a great response. Why not put it in the comments there? The comments are really, really useful for YouTube thinking, oh, that's a good video that people are enjoying, and then they send it out to more people. And I'd like to keep this going, and I'd like to have more of a kind of chat about some good ones and some kind of common errors. So we can only do that if we just share our kind of responses. Don't worry, don't be put off by Harriet, who seems to be absolutely banging everything that I chuck at her. Absolutely brilliant, all of you though.